Good day, everyone. So this video is the continuation of polynomial. So these are the terms that we have to remember in polynomial. So we have constants, variables, exponents, degree of polynomial, and coefficient. So let us discuss first constants. So constants are a term without variable, like 3, -20, or 1/2. Variables, these are letters like x, y, and z. Exponents, these are written at the upper right of the expressions like 2 in y squared and 5 in 7xy to the power of 5. Next is degree, exponents of each term. Fifth is the degree of polynomial. This is the highest exponent, like the 5 in 2x to the power of 5 plus x squared minus 4. If you are going to observe 2x to the power of 5 plus x squared minus 4, there are two exponents. We have 5 and 2. Now between 5 and 2, which is the highest exponent? 5. So 5 is the degree of polynomial. Last term that we have to remember is coefficient. Coefficient is the number in front of variables like 4 in 4xy, 7 in 7x squared. So let us find the following. Given a polynomial x to the power of 6 plus 4x to the power of 3 plus 3x to the power of 2 minus 7. First, let us find the constant. So the constant's definition is, it is the term without variable. So based from our polynomial, where is the term without variable? Okay, so our term without variable is -7. So that will serve as our constant. Because if you notice, among the 4 terms, only 7 has no variable. So therefore, it is our constant. Let us proceed. Let us find the variables. Variables are obviously the letters. Now, we have x. So letters means variables. Variables means letters. So our variable here is x. Let's proceed with number 3, exponents. Remember, exponents are written in the upper right of the expressions. Where are the numbers that are written in the upper right of the expressions? You have it there, the 6, 3, and 2. So 6, 3, and 2 are obviously our exponents. Now, how about the degree? Degree is the exponents of each term. So that means it is still the exponents. So we have 6, 3, 2. Now let's proceed with the degree of polynomial. When we say degree of a polynomial, that means it's the highest exponent. Now again, our exponents are 6, 3, 2. Now among the 3 exponents, which one is the highest? Of course, 6. So 6 is our degree of polynomial. Let's proceed with the last term, coefficient. Coefficient is the number in front of variables. Now, what are the numbers in front of variables? We have 4 and 3. So 4 and 3 will serve as our coefficients. Did you get that? Okay, so let's have another example. Let us find the 6 terms again. Given polynomial x cubed minus 5y to the power of 5 plus 8x squared plus 6. First, constant. Constant means The number without variable. Which terms that has no variable? Very good. The last term. So that is positive 6. So that will serve as our constant. How about the variables? Variables are the letters. So we have x and y. How about the exponents? Our exponents are 3, 5, 2. There you have it. Number 4, degree. So degree is the same with exponent. So we still have 3, 5, and 2. How about the degree of polynomial? Do not forget that the degree of polynomial is the highest exponent. So which among the 3, 5, and 2 is the highest exponent? Of course, we have 5. So 5 is the degree of polynomial. How about the coefficients? Okay, so coefficients are number in front of the variables. So our coefficients are negative 5 and positive 8. If you have questions, comment down below. Adios! So that's how we find the that's how we find constants, variables, exponents, degree of a polynomial, and coefficient. So now, when can we say that the algebraic expression is not a polynomial? Number 1, if the variable is inside the radical sign. Like for example, 4 square root of x. Our variable, which is x, is written inside the radical sign. Number 2, if the exponent is negative. For example, x to the power of negative 2 minus x. So observe that our exponent is carrying a negative sign. Number 3, if the variable is present in the denominator. For example, 2ac divided by b. So b is the variable which is written in the denominator. Number 4, if the exponent is a variable. For example, x to the power of a minus y. If you observe, our exponent is a letter. Number 5, if the exponent is in fraction form. For example, 2x to the power of 1/2 plus 2x. Observe that the exponent is in fraction form. Let's try this. Which of the following is a polynomial and not a polynomial? These are the following statements that will help us tell that the given algebraic expression is not a polynomial. Number 1, 3a squared plus 2by to the power of x. Is there a statement from the right side that tells us that the given is not a polynomial? Yes, there is. It satisfies the rule number 4. The exponent is a variable. So that makes it not a polynomial. Let's have number 2. Given is x squared plus 2x plus 5. Is there a statement from the right side that tells us that the given is not a polynomial? None. So number 2 is a polynomial. Number 3, 5x plus 1. Is there a statement from the right side that tells us that a given is not a polynomial? None. So the given is a polynomial. Number 4, given x plus 2x to the power of 4 minus 5 times 3x. Is there a statement from the right side that tells us that a given is not a polynomial? None. So the given is a polynomial. Let's try number 5. So the given is 5x to the power of negative 2 plus 1. Is there a statement from the right side that tells us that the given is not a polynomial? Yes, there is. It satisfies number 2. The exponent is a negative. So that makes it not a polynomial. So that's how you determine if the given algebraic expression is polynomial or not.